Hello and welcome to today's Tech Tip. Today we're going to be reviewing something completely new. We have a new graphical report called the Digital Twin Face Color Report. If you go to the Output ribbon, you'll see it here just to the left of creating the checkmate whiskers. This is a digital twin report, and what that does is it automatically colors the faces of your CAD geometry based on the worst deviations of the measurements put on those surfaces. So I'm going to go through all the different options. If you look at the part that we have right now, we've got 6 holes on one face, and then there's six holes on the side face here, and we measured all of those as cylinders. In addition, on each one of these 3 different faces, we measured surface measurements, and we got some profiles. And we're looking now over on the right hand side at the reporting browser, and you can see the deviations of all these measurements. So let's go in and make some digital twin face colors. So if you go to the Output ribbon, you'll see just to the left of the whiskers is the Digital Twin Face Color Report. So let's click on it and take a look at the options. We now have 4 options in the list. We can do all tolerances, we can do location and profile tolerances, tolerances of size, like diameters, and form tolerances. So the first thing we're going to do is let's go and take a look at the location and profile tolerances. So we'll say OK to that selection, and I just have one report loaded, one part, so I'm just going to say all and as measured. And here we go. So we've got some faces that have been colored, and we have some holes, cylinders that we measured that have been colored. So let's take a closer look at this. If we look at the faces, these are the profile measurements, and you'll notice the first, if we just scroll down here, there's 12 surface measurements, and we have 4 surface measurements on each one of these faces. So the first 4 measurements are for this front face here where my mouse cursor is. So the way it works, because there's 4 surface measurements on this surface, all with different deviations. In fact, if you look at these deviations, we have a red one here that's on the high side, we have a green one that's in tolerance, we have a blue one that's on the low side, and we have one that's on the high side here, the red one. Now the way it works is, which one of these colors does it choose to color the face? Well, it always chooses the feature that has the worst deviation, the highest absolute value. So if you go and look at these, you can see the blue one here is minus 1.7. So that's the worst case out of these first 4 measurements that are on this blue surface, and that's why it becomes blue. If we look at the next 4, you can see we have a green one, a red one, a green one, and a green one. So of course the worst case scenario is this plus 2.0001, the red one, and therefore that's the worst one, so the surface is colored red. And again, the last 4 here, 9 through 12, you can see there's a plus 1.5, a minus 2.1, and then a couple green ones that are in tolerance. So the blue one is the worst case deviation, and you can see, of course, in the top left, that surface becomes blue. So now if we go in and look at the cylinder measurements, you can see they're clearly all red. And these 6 cylinders where my mouse cursor is on this front face are the last 6. So 12, 11, 10, 9, 8, 7, and so on. And again, we did positions and profiles. Therefore, if we look at these cylinders, for example, look at cylinder 12, it's got a position and a diameter. Notice the position is out and it's red, and the diameter is blue on the minus side. And same as we go up through all these 6, they all seem to be the same. So again, because we did positions and profiles, we don't see the diameter information, so it simply goes off the positions, and all of these 6 positions are all red, and that's why they are red. So if we zoom up, let's look at these 4 cylinders on this red surface, and that would be 6, 5, 4, and 3. And again, if we look at the true positions, you can see we have 2 that are red and 2 that are green. And again, it's just based on the positions and profiles, remember, so the diameters are not included in this report. And of course, cylinder 1 and cylinder 2 up at the top, if you look at those positions, those are both red, and you can see the insides colors there are indeed red. So that's the first kind of report. Let's go in and make another report. Now, instead of doing location and profile tolerances, let's just do size tolerances, and we'll say OK. And all as measured. And there we go. So let's zoom out a little bit. Okay, and this, again, this is just size tolerances, so these would be the diameters. And if we look at the first 6 here, down in the front face where my mouse cursor is, you can see from 7 to 12, the diameters are all on the low side and they're all blue. So of course, the insides of those cylinders are indeed blue. If we scroll up and we look at 3 through 7, again, blue, 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 and we have a red one. And of course, way down at the final end, at the far end there, we have the 2 diameters that are red. And again, this report is just looking at the size, so that would be the diameters. And let's go and look at the final report. Now, form tolerances, we don't have any in this case. Form tolerances would be things like parallelism and like form, like circularity, cylindricity, all of those things. We don't have any in this program, but if we had any of those GD&Ts enabled, we could do a report on forms. Or we can do something on all tolerances, make a report based on everything. Now this is interesting. There we go. So it does everything. It does profiles, and it does positions and diameters. So that leads us to the one final question is, if we're doing everything, and these are these cylinder measurements here represent positions and diameters, how does it get colored? Does it get colored based on the position, or does it get colored based on the diameter? So the answer to that is whichever one is worse. So for example, you can just place your mouse cursor on the colored face, and it will give you a tooltip. And you can see this, in this case, it's using the position, the 0.5. And if we go and look at cylinder 10, you can see the diameter and the position, and its deviation is 1.5 on the true position, but on the diameter it's only 0.09. So of course the worst deviation is the position, and it wins the coloring contest. And because it has a very high deviation compared to the diameter. So that's how we decide who wins for something like cylinders, whether it's diameter or true position. And of course, because we have the 4 surface points on each face, again, the color of the face is based on the worst deviation of all the surface points on that face. Thanks for watching. Hope you enjoyed today's tech tip. Bye for now.